Hi everybody. So today I'm going to be programming a neural network in C++, so let's get right to it. So I'm going to go ahead and I'm going to import IO stream. I'm going to include string, include math.h, include time.h, include vector, and include map. Okay, so I'm going to define int main, return 0. So let me first start off by declaring a 2D vector double. I'll call it x and y. So x is going to be 0.25, 0.33, 0.11, 0.77, 0.42. Okay. I'll add one more, and then I'll make this 0.86. So that's x, and then y is going to be 0.05, um, 0.11, and 0.07. Okay, so the first thing I'm going to do is create the matrix multiplication and the transpose functions. So I will do, and the printer function. So first I'll do void printer, and it takes the argument of a double vector, 2D vector. So I'll just call that x, and I'll do for auto and I in x, for auto and j in I, C out j, tab that, and then do std c out, std end l. Okay, so let me come down here and just do printer of x, printer of y, and I have my shell script in here, so it's going to compile. So I will come over here and do ./go.sh. So it's compiling the neural network right now. It's going to take a little bit, so the terminal just booted. Okay, so now I do ./endnet, and here I have it. So I have the two vectors printed out. So that's good. So what I'm going to do now is do int m equals x dot size, int n equals y dot size, and then I'll come over here and define. Well, actually, I don't need to create a new line. I could just do. Well, actually, no, they have to be in maps. So it'll be std map of integer and then vector 2D vector double, and this is going to be weights, layers, and sigmoid layers. So what I'm going to do now is define a one-dimensional vector. So std vector integer is going to equal axis and r-axis, if you guys remember this from the previous videos. So then what I'm going to do is do for int I equals m. I is greater than n plus, minus minus I. So let me go ahead and see out I and that line. So I'll come over here, do ./go.sh, clear, and net. 654. Okay, so there's three layers between these. So what I'm gonna do is I'm gonna actually come up here and do void dimensions. Um, so it's gonna do command C, and then I will just do std out matrix dimensions. So it's gonna be x dot size, y dot size, and then end that line. Okay, so I'm gonna come over here now and do dimensions of x, dimensions of y. And I'm going to use these a little bit later as well. Let me just compile these. Oh, right. This is actually supposed to be x of 0 dot size. So compile it, clear, dot slash end net. Okay, so that's a 6 by 1 and that's a 3 by 1. Okay, so printer dimensions, now I will do, let's see. I'll do matrix multiplication first, so that's going to be mmult of x, y. So this will be, I'll call it z, and then I will do std vector double temp, and then int, no, double total equals 0. So now I will come over here and do for int I equals 0. I is less than x dot size plus plus I, and that's going to be for int k equals 0. K is less than y0 dot size plus plus k, and then total is going to equal 0, and then for int j equals 0, j is less than y dot size plus plus j, so it'll be total plus equals x of I k. Oh wait, I think I have them mixed up. This is supposed to be x of 0. This is supposed to be y of 0. So it'll be x times I of k times y of k of j. Okay, and then over here it's going to be temp dot clear. Hold on. Let me just double check to see if like, okay, so k equals x0 dot size. That's going down the row. Okay, yeah, I think it is right. So I will come over here and do temp dot push back of total, and then it's going to be z dot push back of temp, and then I will come here and return z. Okay, so what I'm going to do is I'm just going to make a sample. So I don't need any of these anymore, but what I'm going to do is create a sample of 2D vector being multiplied. So I'll call this S1, S2. So this will be S1 equals 2, 4, 3, 1. And then S2 is going to equal 1, 5, 2, 3. And then I will do printer of mmult of S1 and S2 dot slash go dot sh clear dot slash endnet. Okay, so let's see how the maths is the mathing. So I'll come over to the first one. So 12. 2 times 1 is 2. 4 times 2 is 8. Okay, that I don't think that's right. 3 times 1 is 3. 1 times 2 is 2. Yeah, I think there's a little bit of an error with the matrix multiplication. Let's come back up here, or better yet, let me go ahead and make a simpler one. Maybe I'm just like not noticing things. So I'll do dot slash go dot sh clear dot slash endnet. Okay, yeah, this is definitely not, because this should have been a 2 by 1. Yeah, okay, so there's an error. I believe. Oh, okay, so this should have been J, Y0 plus plus J, and then this should have been K. So, no, this is, yeah, this is supposed to be J is less than Y0, and then this is supposed to be K, which is less than Y dot size, plus plus K. Okay, so then now I'll do dot slash nnet. No, go dot sh. Clear. Nnet. Okay, I think this is right now. Yeah, so it's going to be 2 times 1 is 2, 4 times 2 is 8. So that's 10. 3 times 1 is 3, 1 times 2 is 2, so that's 5. Okay. Just to double check it, I'll do 1 3 2 6 dot slash go dot sh clear dot slash nnet. Okay, so now 2 times 3 is 6, 4 times 6 is 24, 30, and then 3 times 3 is 9, 9 plus 6, 15. Okay, yeah, matrix multiplication works. So I will now get rid of all of these, and I will also get rid of S1 and S2. So now I know it works. So then the next step that I'm going to do is create the transpose function. So that's going to be Command C, and then Command V, and then it's going to be transpose of X. So this will be, I'll call it Y, and then vector double temp. And then this will end up being for int j equals 0, j is less than x 0 dot size plus plus j, and for int I equals 0, I is less than x dot size plus plus I. So I will come up here and do temp dot clear, and then over here it'll be temp dot pushback of x of I j. Yeah. And then I'll come over here and do y dot pushback of temp, and then return y. So that's transpose. So what I'm going to do is do printer transpose of x. So dot slash go dot sh clear dot slash nnet. Okay, perfect. So I'll do printer of y just to like double check that they're being transposed correctly. Dot slash nnet. Okay, good. So yeah, these are good now. So I'll take away printer. So now I want to fill axis. So this is going to be for int I equal, or rather, for auto and I in. Oh wait, no, they're not initialized yet. It's going to be for int I equals m. I is greater than n minus minus I. Oh shit, I have to initialize like random arrays of vectors, so that's gonna be let's see, I'll do it right here. So I will call this std vector double. No, hold on. Let me just see if I can paste it. So this is gonna be build vector. Takes the argument of m, integer of n, and random, or rather boolean. I'll call it random x. So let me go ahead and make this z, and then vector double temp. Yeah. So what I'm going to do here is I'm going to do auto dwt equals no inputs, but I'll do this. Do I have time? Yep, I have it up here. So what I'll do is if random x equals true, this will be srand time, or you know what? I'll just do it to all of them. Srand time null. So that way the random numbers will be different on each generation. So then I'll come over here and I will do int num equals 100 and then double dw equals random mod 2 times num plus 1 minus num, and then it'll just return dw divided by 100.0. So actually, I don't think it's supposed to be, because this will give it negative numbers. If I take out the num, it may do the trick. So, okay, so this is what I'm going to do. I'm going to come down here, do build vector. It's going to take the shape of I to I minus 1, and I'll just write false, or rather true, for boolean, and then I'll break this loop, and then I'll do ./go.sh because I want to see it. Did not return. Let's see. Oh, okay. I'll just do like return z, so it gets rid of that error. ./go.sh and net. Okay. Well, I didn't really have anything printing in here, but let me just see this. For int I equals 0, I is less than 20, plus plus I. This is going to be C out of DWT and O. So this is not stochastic calculus. I'm just calling it DWT. So clear ./endnet. Okay, so what I can do for this is I don't want it going to above 1. Or rather, yeah, I don't want it to go below 0 or above 1. I'll do 1.0. Clear. Go.sh. And net. Okay, so instead of fmax, it's supposed to be fmin. Go.sh. Clear. And net. Okay, it's not perfect, but we'll do. So now that I have that, I will get rid of this. So this is going to be for int I equals 0, I is less than m plus plus I, and then it'll be temp.clear, and then for int j equals 0, j is less than n plus plus j. This will be if random x equals true. This will be temp.pushback dwt, else it's going to be temp.pushback 0.0, and then down here it's going to be z.pushback temp, and then return z. Okay, so we got the build vector. So then this will be weights of, maybe I should do it like this. Yeah, I should do it this way. No, wait. How do I do this? All right, this is what I'm gonna do. Instead of build vector, I'm gonna build the axis and the r-axis. So this is gonna be axis dot push back I, and then this is gonna be r-axis. Oh wait, no, it's gonna be reversed. So it's gonna be r-axis equals axis, and then std reverse of r-axis dot begin, r-axis dot end, and now I will come over here again and do for um, auto and t in axis. This is gonna be weights of t equals build vector of t minus 1 and true, um, layers, what did I call it up here? Yeah, layers of t is going to be build vector of t minus 1 by 1, and it's going to be false. And the sigmoid layers of t is going to be build vector of t minus 1 by 1, false. So now that I have that, let me test out r-axis. So this is going to be for auto and r of r-axis, and it's going to do dimensions of weights r. So I'll come over here and do dot slash go.sh. No errors. Oh, it is an error. Oh wait, did I really do a comma up here? It's line 66. Oh wow. um, okay, so go.sh, clear, and net 435465. Perfect. So the dimensions go in order. So now I believe it is ready for learning. Okay. So let me come back up here. I'm going to do int epochs equals 200. So I will come over here and do for int epoch equals 1. Epoch is less than or equal to epochs plus plus epoch. And I'm going to break this line. So what I want to do is here is, so this is going to be forward propagation. So I will do for int I equals, or rather, yeah, I should do it like this. So int I equals 0. I is less than, I guess it depends on the number of layers. So axis dot size plus plus I. So I'll do int index equals axis of I. And then cout index and that line. So come over here, dot slash go dot sh. All right. Clear dot slash endnet. Okay, perfect. So it prints out in here as well. So what I'm gonna do is I'm gonna do if I equals 0, and then break this loop. Let me go ahead and do dimensions of layers of index, weights, so layers of index and dimensions of weights of index and dimensions. Well, actually, I don't need the layers one. I'll just do weights and x. So dot slash go dot sh, clear, and net 6561. Okay, so let me comment this out. If I do layers of index equals um, weight of, or rather, transpose of x, and then do m molt. So transpose of x, m molt of weights of index. Let me go ahead and do printer of layers index. I'll do it here too. Printer of transpose layers index, just so I can see them long. So transpose here, layers of index. Okay, so I'm going to do ./go.sh. I forgot the semicolon. My mistake. Run it. Clear ./and_net. Okay. So there's 5 up here. There's 5 over here. Yes, they went through. That's good. So I don't need printer anymore. So that's if I equals 0. Else, this is going to be, so if it's else, let me remove the break loop from here. Let me do the break inside here. So this, now I will do dimensions of, so wait, yeah, sigmoid layer, S layers of index equals okay, so the sigmoid. All right, yeah, this is gonna be interesting. So where to put it? I'll come over here and do std vector double sigmoid, and it takes the argument of a 2D vector. I'll call it x, and then I will do Boolean dv for derivative. So this will be, I'll call this y, and then I will do, yeah, I'll call it y. So then it'll be for int I equals 0, I is less than um, x dot size plus plus I. So it'll be y dot push back of 1.0 divided, well actually let me just do it like this. I will do double fx equals 1.0 divided by 1.0 plus e to the power of negative x of I. Yeah, yeah, so that's how I'm going to return the vector. And then it's just going to be y dot push back f of x. Oh, I see. Okay, so it's going to be, so if dv equals true, it's going to return, so y dot push back of fx times 1 minus fx. Else is just going to be y dot push back fx. So that's the derivative. Return y. Okay, so now we have sigmoid. So this is going to be sigmoid of layers of index. So then I will come over here and do s, so s layers of index plus 1, comma, weights index. Oh wait, no, I have to do them separately. So this is going to be dimensions of weights of index. So now ./go.sh. Okay, so what did I do? Oh, my mistake. My mistake. Okay. First, this is 2D, so put them in like this. Can't put a float in. Um, x of I 0. So let me go ahead, clear that, run it. Just one more layer. No matching sigmoid. Two arg. Oh, right. So right now it's going to be false. The derivative is false. Okay, so it compiled. So clear dot slash ndnet 1154. Okay, that's a little odd. If I do it like this, okay. Wait, what did I return from here? Okay, why is it giving me that answer? Okay, let's see. I'll break this, and then I'll do dimensions of S layer index. So come here dot slash go dot sh. Oh, did I not put a semicolon? Yep. Clear dot slash ndnet. Okay, for some reason this is returning as a n as a 1 by 1. Let's see. Let's okay, let's try to pinpoint this. So I'll do dimensions of layers of index. It could be this one. Oh. Okay. Um, if I do transpose, let's see what happens. Okay, now it works. Okay, that's good. So, I'll get rid of these. I'll get rid of this break statement. I'll come here and do else layers of index. Oh wait, let me just print out the dimensions again. So this will be dimensions of S layers of index, and then dimensions of weights index, and then break. So this is going to be actually index plus 1, so we could go backwards. Clear that, go.sh, and net 5154. Okay, so this will end up being we get so 51. So this will be layers of index equals transpose mmult of S layers of index plus 1 transpose. Yeah, this math gets much harder like once you use like a language like C++. Like, okay, so transpose of that multiplied by weights of index mmult, and then transpose that. So I believe I have it. So what I'm gonna do is do printer of S layers of index. I'll transpose this just so we could get like straight lines. So clear go.sh /nnet. Okay, good. So it goes from 5, 4, 3. Okay, perfect. So forward propagation has been done. That was something. That was quite something right there. Let's see. So we need to now back propagate it. Shit, my phone wasn't even charging. Okay, my bad. Okay, so now back prop. So this will be 4. So wait, do I have axis over here? Yeah. So it's going to be 4 int I equals 0. I is less than axis. No, r axis dot size plus I. So this will end up being int index again equals r axis of I this time. And then it'll be if I equals 0, if I equals 0, it's going to be the errors. So I have to subtract. So I have S layers over here. I have Y over here. So what I'll do is do dimensions of S layers of index, and then I'll do dimensions of Y, and then down here just break the loop. So clear dot slash go.sh clear nnet 3131. Okay, perfect. So what I can do now is, let's see, I'll come over here and define double calculate error, and it's going to take the arguments of y and y hat. So this will be double, or rather this will be error and return error. So then I will do for int I equals 0, I is less than y dot size plus I is going to be error dot pushback of the power of y of I 0 minus y hat I 0 squared. So I'll return the error. So I will so now let me do this. Error and delta. Yeah, so if I come over here, this will be error equals calculate error between y and S layers of index. And then delta is going to be, let me also come up here and create a function called calculate delta. So same thing, calculate delta. Um, it's going to take the vector of error and it's going to take the vector of layer. So then it will be for, let me just do this as like the delta, return the delta. This is not to be confused with delta in options. This is gradient. So it's going to be for int I equals 0. I is less than, wait. It would just be error. So wait, error and layer have to be the same length, I think. Plus plus I. So, all right, now it's starting to get really challenging. Let's see. This will be double sig equals sigmoid of layer of I, and this is going to be true. Let me just come back up to sigmoid. Yeah, if dv is true, it returns the derivative. Okay. So then this will be the delta dot push back the sigmoid layer times the error. So it's going to be error of I times sig and return the delta. So I'll come over here and do delta equals calculate delta of error, and it's going to be layers of index. So instead of doing these now, I will come over here and do dimensions of error and dimensions of delta. So /go.sh, please no errors. Oh right, my mistake, keep forgetting they're 2D. Okay. So this is gonna be 0. This is gonna be 0. 0, 0. Maybe that was the only error. Another 4 errors. No matching function called sigmoid. What does that mean? 97. Oh. Okay. So clear that. Okay, so now I have 3 errors. No matching function called to sigmoid. Oh, okay. Um, wait, no. It would be the index. Okay, yeah, I think it's int index. So this will be index and then I. Yeah. But error is I 0, so that's good. So it's a matter of just oh wait, no, no. It is I of 0, not index. So let me open a new terminal just so I could start over, and then I will do /go.sh. Okay, so let's start from the top. So no matching function called sigmoid. It takes a 2D vector. Um, so maybe it's just layer. Oh, and also it has to be a okay. Oh, I see. So let me cut that out here. Let me paste that out here. Let me convert it to. So I'll call this sig equals sigmoid. So it'll be sig of I of 0. So now let me open a new terminal. Do /go.sh. Okay, so the errors resulted. Oh yeah, the delta has to have them in parentheses. Clear that. Go.sh. Perfect. /ndnet. Okay, good. So they're both 3 by 1. Okay, so now I will get rid of this, and then delta will actually be. Oh wait, so I didn't properly calculate this derivative. Um, it's supposed to. I could just do it in the code. So come to calculate delta. So this will end up being okay, so we already got the sigmoid layer. Error. Wait, what was I saying? Oh yeah, yeah. So this is supposed to be 2.0 times error. Yeah, yeah. Okay, so I've managed to do that. Now let me go ahead and do the separate layers. So else. So now I want to multiply the weights. So I'll break this line, and then I'll come over here and do dimensions of delta and dimensions of weights of index plus no, index minus 1. So I'll come over here, run go.sh, clear that, and net. Okay, so 3143. So let's try this. I will do error equals mmult of weights of index minus 1 and delta, and then I'll do dimensions of error, go.sh, clear, /ndnet. Okay, good. So now I will get rid of these, but I have the error dimensions. I need the, so the new delta is going to be, okay, so the delta, ah, shit, I guess it would just, hang on, okay, that was the initial one, yeah, so 2 times error times sigmoid. This delta is going to be, so I'll copy this, calculate delta 2, Um, so I'll get rid of the 2 point. Hang on, wait. Let me just write something out. So error. Wait, hold on. Actually, you know what? Forget it. I will just try it out. So delta is going to be delta. No, calculate delta 2 of error and layers of index. Um, and then do dimensions of delta. So dot slash go dot sh and net 4 by 1. Okay. So now I believe I have everything. So what I'm gonna do is do dimensions of delta. It's not gonna go through the epochs though, but we're getting close. So clear dot slash and net. Yep, 5 by 1. Perfect. So now that I have all of that, what I have to do is, well, let me go ahead and just print out the dimensions of delta, dimensions of weights of index minus 1, and then cout and line dot slash go dot sh clear net seg fault core dumped. Okay. Oh yeah, that was just because of like. Okay. Well, we have them. We have them loading. I believe what I should do. Oh wait, now I have to propagate the weights. Okay. So back propagation's done. Update weights. So okay, I will come over here to map because this is how I'm going to do it. I will call this gradient. So gradient is going to be gradient of index equals delta. Okay. So now what I'm going to do is do for auto and I in axis. So I'm going to print out the dimensions of gradient of I, and then the dimensions of weights of I, and then cout and that line. So dot slash go dot sh clear and net. Oh, did it do all the epochs? Oh man. Okay, well, at least I can see what's going on here, so I will simply do. Okay, so it'll be, so that's gradient, and then weights. I just have to subtract them. Okay, so yeah, let me come up here now and do, under sigma, under calculator, do double. No, rather, it'll be 2D again. So Command C, Command V, um, update. So it's gonna take weight, and it's gonna take gradient. So then I'll just simply do for int I equals 0, I is less than weights plus plus I. For int j equals 0, j is less than weights 0. Oh yeah, I need to do dot size. So weight 0 dot size plus plus j, and then it'll be weights of ij minus equal transpose of gradient of 0j return weights. Okay, let's see. So if I transpose grade, well, yeah, let's just try it out. So it'll be um, weights equal, no, weights of I equals gradient, or no, update of weights of I and gradient of I. Let me go ahead and do break, and then, well, actually, I don't need to. I'm going to get rid of these, and then I'll see what is right. So what I want to do now is printer. So I will do printer of transpose of error. So now let's see if this works. So it'll be go.sh clear /net. And here we have it. So the error is minimized. Yeah, we start off with these high errors and then it goes down. So yeah, C++ neural network right here, folks. Well, let's see. What can we do now? You know what? I think we've done enough. I thank y'all for watching my video. I'm going to keep coming out with more and more good machine learning content, so stay tuned and peace out.